Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be going over Eloquent JavaScript, going over Chapter 5 today, Higher Order Functions. So we're going to kind of build on what we talked about last time, if you guys remember what we talked about last time, and I didn't include it on the slides now, but we talked about data structures, arrays, and objects. We talked about all the different methods that you can do to arrays that are included, methods that are included in arrays you can access via dot notation. We talked about objects and a little bit on JSON too, and the kind of the difference between those. And if you guys remember, you can convert JSON to a JavaScript object and vice versa. Why is JSON important? It helps with getting over the cross-domain errors and helping to transfer it across like an HTTP request. So last episode was really long, and we're gonna kick things off just right away now. This one won't be as long, thankfully, hopefully. We'll see we'll see where the mood takes me, and hopefully we don't get too in the weeds for you guys. I was looking at some of the documentation for some of these functions that we're going to talk about, and I was just thinking to myself, oh, that's a callback function. Oh, that's what a callback function is. And we'll probably hit on that later, but a callback function essentially is a function that gets called on every iteration of the loop in an array. Hopefully, I'm not getting too in the weeds right at the start. That's always just a good thing. No, let's kick things off. Higher order functions. Let me grab the book. Higher order functions. So Mergen starts off this chapter talking about abstraction, and this immediately made me think of Java, because in Java, one of the principles is abstraction, and how people say that you write classes in Java in order to abstract when you don't want somebody to see the details. And that's exactly the point that Mergen hits on in this chapter as well. Abstraction is, as Mergen defines it, is hiding details in order to talk about problems at a higher, more abstract level. So can we abstract an action as a function? Absolutely. So what is this going to mean? This is going to mean that you basically hide the details of an action within a function, and then you just call the function. So let me see if I can get this right. Let's say we have an action. Let x, I always start off like this. Let x equal to 5. Let's do a for loop. Let y equals 0. Let's go until y is, as long as it's less than 5, we'll do y plus plus. And let's return. Y plus 5, let's say. So we have, right, this action. Let's say this, y plus x. This action that we want to do here. And okay, maybe we wouldn't do a return because this isn't a function. Console.log. Let's do x plus y. Let's do x. Let's just do 5 plus y here. So we have this action, right? We have this action, And we can just keep writing. And I know I totally get it. I know there's this undefined there. This is just kind of on the spot. I just work with me here for a second, guys. The main point to get here is that this is the action, right? And you can keep calling this action throughout your code whenever you need it. Maybe there's going to be a point when you need something, you need 5 added to like every iteration of an array, right? Maybe that's what you need, and we learned before that you can take that action and put it in a function and just call the function, right? So we could take this action, function add 5, let's say x, and then let's say x plus y. So now turn x if I call this, oops, I need another bracket. There we go. So now if I call this, add 5, and let's take the x that we did up there, 5, and this is going to return right away. So it returns 5 because the first iteration is only going to run, because right after the first iteration runs, we're returning this. So y is set to 0. Is y less than 5? Yes. So it's going to return x, whatever we pass in for x here, plus what is y again? 0. It's going to return 5, which is what it does here. Okay. And then it just exits, returns, it exits the function. So now we can keep calling this function in other places. Look, that's going to be 6, right? Add 5, 100. It's going to be 100, right? And the details are hidden within the function. So yes, the action can be abstracted as a function. So the details are hidden within the function declaration, however you want to do it. If you want to do it this way, or if you want to do it the arrow function way. And then you just call the function with whatever parameter that you pass in. So yes, that definitely can work. That is a way to do abstraction. Now let's get into the weeds, because functions, as you guys can kind of see right here, function add 5, what gets returned in the console is the fact that it is a function. You can see there, function add 5. Now, let me demonstrate this a different way. If I didn't have the parentheses here, and let's see, if I just said add 5, look at what is returned, object function. Because I remember I said this last episode, I think, everything in JavaScript is a function, or everything in JavaScript is an object. Yes, that goes for functions too. So this right now is returning like the type that this is, which is object function. Now when you bring in the parentheses, this is like calling, actually executing this function. All right, so functions are objects. So what does that mean? Well, you can kind of do stuff to them in a similar fashion that you can do stuff to objects, like pass them in as parameters to other functions. So take a look at the slide. Higher order functions, what are these? These are functions that operate on other functions. So functions taking functions as arguments, or functions that return other functions. So it allows abstraction over actions. not just the values. So you're hiding the details of the actions. Now there's 3 ways to do this. Create these higher order functions. It's either functions that create new functions, functions that change other functions, or functions with conditionals. So what do I mean by that? Filter function for arrays. That is kind of one of the ways. We're going to talk about that in a second, but let me try something with you guys. Functions that change other functions, functions that create new functions. Okay. So we got this add5 function, right? Let's get rid of this. Okay. Add5, right? What happens if I say this? X, we're going to return a function that returns another function. How about this? X plus equals 5. And we're going to take 5. And we're going to return another function. So what is this doing? This is going to take in a parameter, x. It's going to add 5 to it. Then it's going to return a function, that adds 6 to x. So consider, this is a whole entire another function. This is, we're returning an arrow function here, right? So how would we call this add5? Because I don't even think we're going to be able to do it like this. I didn't think so. I don't even think we're going to be able to do it like this. Right. What's going to need to be done, this is returning a function, right? That's what you see here. Remember before this was printing, right? Because we were returning the value, like 5 plus 5. This was, or 4 plus 0, this was returning 4, right? In this case, this return statement is returning the arrow function. That's why we're getting this object function there. So let's assign it, right? So we're assigning it to this variable assignment. This is our binding. So the function that is returned, this arrow function, should now be bound to this assignment. So if I do this, we're getting a function, so that's good. Now this is going to take in a parameter. So let's try 4 again, and we get 10. So it's a little confusing. Let me see if I can explain this. We call add5 with a parameter of 4, right? Right? So this gets set to 9. Doesn't really do anything, though, because now we're returning a separate function, essentially like here, this is taking an entirely different parameter, x, unrelated to this, because this would be x equals 9. This is, and I believe this has to do with the scope. This scope here is completely different than this. You got to remember, this is a completely different function, right? So add5 returns a function. We're assigning it to assignment. This is no different than if add5 returned a value, right? This is no different than if add5 returned x. Now this is returning 9, right? No different. This just returns a function now. So we have to assign this to a binding. Now, I'm trying to think, is there another way to do this if you just call like an inline add 5 returns a function? There probably is. I don't want to confuse you guys though, so that's why I'm assigning it to this assignment variable. So this assignment variable is now holding this. So now we can call assignment parameter. It's taking in just one parameter, right? X. So we pass in 4. What's 4 plus 6? 10. So it's almost like this is disregarded. Now, if I wanted to include this, let's say let include equal to that. I wonder if this is going to be allowed. Okay. So now this include, right? So now we have a binding, and now we are calling this binding in the function that is being returned in the add5 function. Lots of functions being thrown around here, guys. This is possible because of scope. So this exists outside of the scope, and because of that, it exists outside of this local scope. So you can call it in there. Now, you can't go vice versa, right? You can't, if I was to say in this function, let include you can't call it outside of that scope. But because this is global to this, it is allowed. So now add 5 takes in a parameter 4. It's going to add 5 to it. So 9, right? Oh, and gosh, I don't even need to do this anymore. I can do that. So this is 9, right? Then it's going to return a function that takes an x and adds 6 to whatever the sum is here. We assign it to this assignment variable. And now that assignment variable contains this, and this contains one parameter. So you need to pass in one parameter. If you do this, you're going to get the not a number or whatever, undefined, whatever it is. Actually, you still get 15. That is really strange. There you go. There's that. And then what if I do this? Oh, I get 15 still. Oh, I know why. This is what I originally wanted to do. Okay, now you're getting the not a number because it does take in an x parameter, but I wasn't using it in here. So now x plus include plus 6. You're taking the sum here plus 6 plus whatever you're passing in. So now if I do 4, this is going to return 19 because you're returning 4 plus the whatever here, the sum here, and then plus 6 to get 19. So this would be like an example of function that returns another function, right? But you can also have a function that takes in a function. So like function add 6 is going to take in, let's say x and an action. I'm going to say action x. Return action x. Now let's create another function down here. Take in, how about this? Make number negative. It's going to take in one argument. And all this is going to do is this is going to return. Now, how do I want to do this? Add 6. But then it returns this. So it's almost like I got to switch these names around because I want to add 6 here and then make number negative. No, let's just continue on with this. So return negative y. Don't worry about this name. Let's just call this function name. Return action x. This is just a random function, right? So now, when I want to call function name, it's taking an x and then an action. So it's taking in a function, right? So if I want to call this function name, let's say 5, and then make number negative. Look what's returned, negative 5. Do you guys see how we got to that? Function name takes in 2 arguments. It's going to return one of the arguments with a parameter of x. So a function. This is taking in a function. We have a function here, make number negative. We're passing that in and the 5. Right? So that's here, make number negative. So make number negative. So that's what this action is. Make number negative 5. Passing in 5. So now you come down here. Y is equal to 5, and you're returning negative y. So negative 5. That's what you get down here. This is like super basic. Sorry about the weird function names there, but now you have a function that takes in a function as an argument. Higher order functions. You're masking, you're hiding the details here. So when you call this, you don't know what make number negative does. You don't know what function name does. I mean, yes, you can scroll down in the code and look at it, but maybe the function, maybe your functions are in a different JS file, maybe in like a module, or you make it an module or something, and you can import it into like your main JS file where you work on things. So anyway, that's just like a little bit of an introduction into that. And then functions with conditionals. Functions with conditionals. Oh, because I'm pretty sure you could do a conditional check. Let me take a look. You can do a conditional check in the function. So test, if test. Then I'm just looking at the book here, guys, really quick. Oh, right, yeah. Yes, you can have functions that perform a conditional check that like you pass into here as the action. Yeah. Okay. So let me see. Let me attempt to do this for you guys. Function name, make number negative, and then let's say we have a function conditional check. Gonna take in x. Tell you what. X. Okay. And then the action? Conditional check. Action. How do I want to do this? Because we want to return a check here. A check here. Return if x is less than return x is less than 5. Right. Return x is less than 5. So maybe we would have to do another conditional check here. And then we could say here, if condition X return else return no dice. Okay. So now let's call condition check. Boom. Okay, that semi works. So yeah, really sorry guys. This is getting I'm gonna delete this next slide, but now function name. Take a look at function name, what we did. It's taking in two functions now, right? Cond and action. Cond and action. And you don't know this just by looking. You might not even know this by just looking at the params, right? You might not be able to tell that, but it's how it's implemented in the function that you're going to be able to tell. So if conditional X, right, if this is true, then we're going to return the action X. Else, we're going to return no dice, right? And then action X is its own separate function, right, that we're passing in, right? So you know just by looking at this, though, that this is going to be a conditional check. This cond, I know that's a weird name for a function, is going to return a Boolean. Come down here, con check, X, takes in X. It's going to check if X is less than 5. Right, so now when we call function name, we're passing in 5, make number negative, and the con check. Now check out what happens when we pass in 5. Is 5, right, it's going to come here, cond of 5. That's what we're passing in, cond check. Is 5 less than 5? It's not. So this doesn't get executed. Instead, this gets executed, and that's what we have down here, no dice. So anyway, this was just like and I never really have used this before. I never really knew this about JavaScript, that you can pass in functions as arguments. You can do the same thing in Java actually as well too, which I thought was kind of cool. So anyway, guys, I'm going to clean slate. Let's move on to some functions, some methods for these arrays. So first we have the filter function. Filter function. So what this is going to do, specifically for arrays, filters out elements in an array that don't pass a test. And it's going to return a new array, but it does not modify the original array. So if I have an array here, let array equal to 1, 2, 3, 4, 5. And let new array, because this is going to return an array. Now, you don't have to assign this to something. You can just call it. But you would call it like this, array.filter. And if you look at the documentation on MDN on Mozilla, there's optional arguments here. But basically what you're doing, this is going to take in a callback function with parameters, and then the function body is going to contain the thing that you're filtering for, the test. Because you want to filter out if things pass or fail the test. So think about, in these scenarios, you see it very commonly written as an arrow function. So just think, inside the filter, I want to pass in a function. So my arrow function, so let's say X, and we're going to do a check to see if X is less than 3. So now as you can see, 1 and 2. So what happens, we're going to bind it to this new array variable. Now, what filter does, this is, I believe, what's called the predicate, if I'm not mistaken. This is at each iteration, the thing that's at each iteration of this array, because this filter is going to be looping through here and doing this check. So it's like for each x of the array, where x can be whatever your array is, if it's a number, if it's a string, it's whatever it is. It's kind of like similar to doing like a for of, or for each, right? Just think about it like that. For each element x in the array, we want to check if x is less than 3, right? And it's only going to return the elements of that array that are less than 3. So in this case, 1 and 2. Now check this out, because, like I was saying, the original array was not modified. So if I print array, you're still going to get 1, 2, 3, 4, 5. So that's the filter method. Just think, filter, you're filtering out the array, and you only want certain elements from that array. So you're filtering out based on if they pass a test. The next function we have is the map function. And what map does is it applies a function to each element of the original array. It basically manipulates each element of the array. And it returns a new array, and it does not modify the original array. So you map it to a new form. So let's say let mapped array equal array dot map x. And we want to do, let's say, x plus 1. So for each element of the new array for each element of the original array, we're just going to add 1 to it and return the new array. So as you can see there, I don't have to type this again, but just for clarity, mapped array now returns 2, 3, 4, 5, and 6. So essentially we added just 1 to each element in this top array. So what do we have so far? We have filter and we have map. Filter is when you want to filter. I'm trying to think of another word besides filter, but if you want to exclude items from an array that don't pass a test, when you want to filter out for certain elements of the array. Map is when you want to apply a function, when you want to apply some sort of like calculation to each element of the array, or manipulation or something of that nature. Next, we have the reduce function. The reduce function kind of confused me in the beginning, but what it says here, builds a value by repeatedly taking a single element from the array and combining it with the current value. It reduces the elements of the array to a single value. So think about conceptually just looking at the array example that we have. It's going to take all those elements, combine them into a single, reduce the elements of the array to a single value. So in a very simple example like addition, if you wanted to reduce and you wanted to add up, take the sum of all the elements, that's where reduce would come in handy. Reduce would say, okay, we're going to take 1 plus 2. Then we're going to take the sum of that and we're going to add 3 to it. Then we're going to take the sum of 1, 2, 3 and we're going to add 4 to it. Then we're going to take the sum of 1, 2, 3, 4 and we're going to add 5 to it. It reduces it down to a single value. And just like the other methods, there's a callback function on each element of the array, passes in the return value from the preceding element. Now, again, it doesn't modify the original array. What was I going to say? But it's going to be passing in two variables into the callback function. So let reduced array equal to array dot reduce. Let's do it like this, and it's going to take in 2 elements here, and I will explain what these mean. X plus Y. Yeah, okay. So remember before, like with the filter, we just have one argument in this callback function here, just X, just the current iteration, right? Well, it's the same in the reduction callback function, but you have an X and a Y here because you need the current value and the next value, or the previous value and the current value. Actually, let's look at the documentation for this. We want reduce prototype array.prototype.reduce. Yep. Previous value, current value. Okay. So this is kind of essentially how I did it here. So this is the callback function, right? This is what's going to be done to each iteration of your array. But it takes in, again, what was it? Previous value and a current value. Previous value and a current value. So, let's say you're reducing your array, you come to 2 here, right? Current value 2, previous value 1. So it's 3, right? 1 plus 2 is 3. Then you come to 3 here. 3 is the current value. What's the previous value? 3. Previous value. Notice that, and hopefully I didn't say this moments ago. Hopefully I didn't say index. I said value. Again, it says previous value, not index. So the previous value was the previous summation here, 1 plus 2, which is 3. 3 plus 3 is 6. Now you come to 4. Y is equal to 4. X is going to be equal to what? 1 plus 2 plus 3, which is 6. And then you keep going until it reduces down to one value, which is 15, which is the case here, because what's 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5, 15. We just reduce this array. Now, I'm going through these very basically with you guys. There are other things to understand about these functions: filter, map, reduce. And it was this, the use of this. Namely, in here, function callback, previous value, current index. So this does take in an argument of a current index where you want it to start. So I wonder if we tell it to start at index 1, would this do anything? Assigning to R value, no, that wouldn't do anything. Current index, X, Y, Z. I don't even think that would do anything. Takes in the current index. See, but you can use other, takes in an array. There's optional arguments here, initial value. And there's ways to use these: previous value, current index, optional, initial value, optional. There's these optionals here, basically, is what I'm trying to say. And I'm kind of doing it in a very basic way with you guys. Return previous value, current value. And then 10 current. Anyway, That's reduction, guys. So if you're, maybe we'll do another video on just those optionals. Because, I mean, here, just for clarity's sake, if we, there we go. If we do filter, array filter, see, these also have optional arguments, element, index, array, this argument, which is this, like the context of this in JavaScript. Dude, we need a whole new video just to talk about this. I was getting really confused on this because this means something differently if you're calling it in a function versus outside of the function. Is it dealing with the global context or for the object context of what you are calling? You want me to get into the weeds? Whew, we could talk about that. But I don't think that this really, it doesn't really work in here, because I tried doing this dot my object equals a50. And then when I call my this dot a, let's try this, undefined. Okay. Oh, right. No, I can't do that. I'd have to say this dot my object dot a, and then I get access to it. Okay. Let's not even go there, guys. Let's just continue on because we just got two more functions here. Sum. We've got the sum function. So sum checks if an element in the array passes a conditional check and returns a Boolean. So this, unlike filter, you're not building a new array. You're just checking to see if one element in the array passes a conditional check. And if it does, we're just exiting and we're returning a Boolean. So let my bool equal array dot sum. We're going to take an x. We're going to check if x is less than 3. So true. There is an element in here that is less than 3, and it's the first index. So it automatically returns true. Now, what if you did greater than 3? Well, this would also be true because we have 4 and 5 in our array. But what if we did greater than 10? We return false because none of the elements in our array are greater than 10. So that's the sum function. And then we also have the FindIndex function. FindIndex function. This is going to return the index of the element in the array that matches a certain conditional. So it returns a number, like an integer. If it does not find an element that satisfies the condition, it's going to return a -1. So check this out. We'll just recalibrate this and we'll say FindIndex. So check this out. It returns a -1 because it's going to do this check, right? For each element of the array, is that element greater than 10? Is 1 greater than 10? 2, 3, 4, 5? No. So it returns a -1. Now, if we did here, let's say greater than 3. It returns 3, right? The third index, 0, 1, 2, 3. That's 4. Is 4 greater than 3? Yes. So it's going to return the index that 4 is located at. But 5 is also greater than 3, right? How come it doesn't return 4, which is, it's at the 4th index? Because it's going to return the index of the first element that it sees, right? It's going to loop through this. It's going to loop through this until it finds the first element that does. And once it finds it, it's it's going to return it, right? So if you're trying to find everything in your array that satisfies a condition, it might be better to use the filter method, because that way you'll get, right, you'll get every number here, right? We got 1 and 2, every number that was less than 3. But when we do it here, right, this just gives us the first index, and we don't even know what element is at that index. I mean, we do, but like, let's say maybe we didn't. I don't know. So just basically what I found out this chapter is there's many different ways to use functions. And there's methods for arrays. There's functions that you can do on arrays that are like built in the JavaScript, like map, filter, reduce, FindIndex, sum. There's all of these at your disposal in that you can use to create new arrays from original arrays and do conditional checks on arrays, do, searching on arrays. So that's really a really cool thing with JavaScript. You can do the same thing in Java with streams, and you can do these, filter, reduce, map. But in JavaScript, you don't have to use those streams. So it's pretty cool. It's just out of the box like this. And oh yeah, I did want to show you guys, just you don't have to assign this to a variable. Like if I wanted to, I could just do this, right? And you could still call it. You just got to remember that this returns a new array. So you're probably going to want to use the new array at some point. That's probably why you're filtering out the original. So it works out pretty well to assign it to a variable. And then you can utilize that, your new array now. Because like this, it's not really assigned to anything. And you're not manipulating the original array, right? So just keep that in mind. Guys, that was it for this chapter. There was other parts where Merjan talked about scripting. It was kind of like a story problem. I didn't really get into that because he was talking about Unicode characters, and kind of utilizing the principles of higher order functions and these array methods, these array functions, to kind of solve like a little puzzle regarding scripts, characters, and the Unicode value of the characters. Because if you guys remember, like these, values get converted in memory, right? 4, 5, and in memory they're represented by bits. So there is basically these end up getting converted to the ones and zeros, right? So before it does that, there is like a Unicode representation of it. And then eventually that Unicode representation gets converted to the ones and zeros. And anyway, I'm getting in the weeds. Guys, this was a fun one. Thank you very much for listening if you got this far. If you have any questions, please don't hesitate to ask. I'll do my best to answer any JavaScript-related questions or any coding or any questions at all. If you want to know anything. We got the blog out now too, so I'm putting out posts on my friend Ted Moss's book, Look Out, I'm Parenting Here. That's on Ghost. Link for that is in the YouTube channel. Maybe I'll include a link to that in this description as well. I won't do blog posts on anything coding related just yet. And thank you guys so much again. Really appreciate it. Big things coming. Thanks for sticking with me. My name is Chris. This has been Chee-Tash. Take care.